Like giant exclamation marks, skyscrapers punctuate the story of our urban development.
People always want to reach. There's something heavenly about it, and people have wanted to race for height forever.
Developed by the pioneers of architecture in the late 19th century.
They were, at the time, the equivalent of our going to the moon.
These magnificently designed tower giants urbanized some of the greatest cities in the world.
It's about defying gravity and leaving a sign of humanity.
From Chicago to London, from Tokyo to Dubai, skyscrapers have and continue to define our contemporary way of life. The 1970s was an era of pivotal change in the United States. After a decade of optimism and prosperity, the country was now suffering through an economic crisis. The economy was in recession, and cities like New York saw a decline in manufacturing, and with it, fewer industrial jobs. By 1974, 500,000 people were out of work, and the city was on the verge of bankruptcy. Demographics were also shifting. With crime rates at an all-time high, middle-class families began to abandon the city. But out of the ashes rose the World Trade Center. Spearheaded by David Rockefeller, the urban renewal project was intended to help revitalize Lower Manhattan.
The World Trade Center site and the Twin Towers, ironically, was really the first time where a government agency participated in a large-scale skyscraper development project. And the idea was to kind of give it sort of a shot in the arm, if you will, because they had this large site and because they were interested in sort of projecting New York City on the world stage. The Port Authority decided to build the Twin Towers, the world's largest buildings at the time.
At 1,368 feet and 1,362 feet, respectively, the World Trade Center assumed the title as the tallest buildings in the world.
The World Trade Center site is very large, and many small mom-and-pop type shops were displaced, and so that whole neighborhood, which was a bit gritty but still vibrant, was destroyed. So that caused a lot of controversy. And I think many New Yorkers, as is typical for new iconic projects, they thought those two buildings were pretty ugly.
They didn't think it looked like a building. It didn't have a crown. It didn't have the typical, sort of physique of a skyscraper. And the fact that there were two of them made it marginally better, but not great.
Even though the World Trade Center received criticism for its generic design and brutal scale, the towers contained many innovative structural engineering features.
It was one of the world's first tall buildings to use what's called a framed tube system. So a lot of the structures placed on the outside of the building were these columns with very close proximity to each other, just a couple of meters apart, all pushed to the edge of the building. Now, what that did is it made the floor plate open plan, allowing for the businesses at the time to thrive.
Now, the other innovation of the World Trade Center was the pressure equalized facade. What it is a facade that is able to control the weather and keep the weather outside of the building by equalizing the wind pressure inside the depth of the facade system. It's a very clever approach that controls basically waterproofing by opening gaps in the facade. And so it was a test bed with, for the first time, these two very important aspects of wind engineering and pressure equalization of facades happened in that one building.
So the building was one of the first to use what's called a sky lobby elevator system. And in that, occupants would travel on shuttle elevators to an open floor, and from there move to local elevators which serve individual floors. And that made the whole vertical transportation process much more efficient, and it meant the core was much smaller.
New York has always embraced these vast projects with a sort of a mix of disapproval and approval at the same time.
They were a little bit like aliens in the fabric of downtown, and they seemed to tip the island a little bit over to the west side. They didn't participate in the shaping of the skyline.
And as the need to build taller and stronger was increasing, the relationship between architect and engineer was changing. From conception to completion, it takes a village to build a skyscraper.
There was a huge number of people involved in designing a skyscraper. It's a very complex machine.
You may have a lead consultant that can offer all the services, or you'll get maybe an architect that will bring an engineering team. So you may get, 20, 30 different stakeholders within the design team.
An architect doesn't need to know as much about structures as a structural engineer does, but he or she needs to have some understanding so that they can design better and also communicate with the structural engineer better, and vice versa.
The job as a skyscraper architect is to listen to everyone, to synthesize what they are telling you, and to channel that into the design.
Thanks to architectural trailblazers of the time, Skidmore, Owings, and Merrill, this collaborative approach became the standard in Chicago during the 1970s.
We do architecture with a capital A and engineering with a capital E. It's pretty rare. And the three people, Skidmore, Owings, and Merrill, have long since passed away. So you have a bunch of people, architects who like working with engineers who like working with architects, and who are not so driven as to get their name on the door, but are driven.
Bruce Graham and Fosler Kahn were SOM's dream team in the late 1960s, early 70s. Their greatest collaboration was the 110-story Sears Tower.
In the 1970s, you had the kind of competition between the Sears Tower, the Hancock Tower, the World Trade Center, the second boom of the American skyscraper, with these latest generation of towers competing to be the tallest in the world.
Chicago has always been a pragmatic city, fundamentally, and I think architects in Chicago have maintained a very kind of pragmatic approach.
While designing the Sears Tower, Graham and Kahn determined that the framing structure traditionally used to construct tall buildings was inefficient. So they opted to devise their own. The bundled tube system increased buildings' overall stability, eliminated internal wind braces, and maximized usable interior space. It consisted of numerous narrow cylinders bundled together to form a thicker, more substantial structure.
Sears Tower pushed engineering and aesthetic expression of the tall building in certain directions, and certainly with structural expressionism, the idea of expressing the structure on the exterior of the building.
I have 4 pieces here and 4 pieces here, same size and same length. So if I hang this from this, you see that it bends quite a bit, right? In this case, I have the same 4 pieces of wood, but they're glued at the end, so they act together like a bundled tube. Now you see that it bends a lot less than it did before. What we're getting here is one structural member which is considerably stronger and stiffer. As you go up, you cut off some of these tubes because it's not needed anymore. As the building goes up, it becomes smaller in footprint. But everywhere that these tubes touch one another, they're interacting with one another, they're locked to each other, and therefore there's no slippage.
50 years ago, the tall building was largely a technical challenge. How high can man go? How high can man put materials above the plane of the earth? What are the structural solutions? What are the air conditioning solutions and lighting solutions? How can he do that safely? So we were doing the architectural equivalent of walking on the moon with those buildings in the late 60s.
As skyscrapers reached new heights in the United States, another country was asserting themselves into the race. Looking to share his groundbreaking structural engineering concept down under, Fazlur Khan headed to Australia, hoping to make high-rise history. As the second largest city in Australia, Melbourne has repeatedly taken a backseat to Sydney in terms of population and location. But by the 1970s, this cultural capital experienced a sudden skyscraper boom. Designed by Yunkin Freeman Architects, along with the assistance of structural engineer Fazlur Khan, the elegant 41-story BHP house on William Street became Melbourne's first skyscraper to surpass 500 feet.
That building was an icon for the corporation of BHP in Australia, but was also a test bed for the belt and outrigger truss systems, which are used worldwide today to stabilize building against the wind.
So the outrigger system consists of huge super columns on the perimeter of the building with a truss, or normally a truss or a large structure that links these two together.
Where you have the central spine, and then you reach out at certain levels to grab the perimeter to resist the overturning force.
The core outrigger system became very popular because once you have that, you can have the facade really open. You can put a lot of glass there. The architects can articulate the facade in whatever way they want. And the concept is very simple.
Due to an array of innovative structural design components, the BHP house stood apart from other skyscrapers of its time. The building generated its own electricity using natural gas. New techniques using steel and concrete redefined the building's structural design. Unlike traditional layouts, the open floor plan allowed for more use of the internal space, and the sheer glazed exterior curtain walls increased the building's overall efficiency. It was clear that Australia was breaking away from traditional architecture and influencing the future of engineering.
Australia became so confident building with concrete to the extent that it even developed its own techniques that were unique from the rest of the world. And it led the world sometimes in the concrete construction from the 60s through the 70s. For example, the jump form technique of construction, of course, was patented in Melbourne in the mid-70s. And that is the same technology that was used to build the Burj Khalifa in Dubai.
Back in the United States, one of the nation's oldest cities, Boston, was on the verge of its own architectural boom. Looking to distinguish itself from other cities across the country, Boston was eager to create a significant architectural landmark of its own. Architect Henry N. Cobb and the design firm were assigned the task of creating the John Hancock Tower. Their challenge: to design a modern skyscraper that wouldn't overshadow the historical landmarks that surrounded it. Their ingenious solution? Glass.
What the architect tried to do, Ian Pei, was to have a facade that was double glazed, and it had curtain wall panels that were stretching from floor to floor.
To make the face of the tower appear smaller, the design team used reflective double-layered mirror glass. The material allowed the lower levels of the tower to reflect the buildings in the surrounding area, allowing the rest of the tower to seemingly disappear into the sky.
So it was a fairly large piece of glass, double glazed. It was quite different from the one we had today. So the spacer between the double glazed unit was soldered to one side of the glass. And because the glass was reflective, it had a reflective coating that was soldered also through the spacer.
There was a new material, and so this question of risk, new technologies come with risks.
When the John Hancock Mutual Life Insurance Company bought this design for their new Boston headquarters, They figured the reflective glass would present a picture of the city in its best light and be a good reflection on the company as well. That was before the reflective glass began popping out and splattering downtown Boston.
And so under certain wind conditions, these glass panels started to fail under fatigue, and they started to fall.
In the winter of 1973, prior to its completion, the Hancock Tower tragically started to fall apart. One by one, its mammoth glass plates started to pop out and plummet hundreds of feet to the street. The design failure provided architects with an opportunity to learn from its mistakes.
It's a relatively small step to say, right, we will not mechanically glaze this glass onto this building. We will actually stick it on with silicon. But then you roll that out at the scale of the John Hancock Tower and you have a real setback.
Now every painful pane is being replaced by CDX-grade plywood, worth about $126,000. Eventually, a different type of glass will replace the plywood at a cost of more than $7 million.
Engineering is what it is. It's actually problem solving in uncertain conditions. Therefore, it is inevitable that occasionally it will jump out and bite you.
From its development, Citicorp Center, now the Citigroup Center, was an engineering challenge. When planning for the skyscraper began in the early 1970s, the northwest corner of the building site was occupied by St. Peter's Church, one of the city's historical landmarks. Luckily, the church allowed Citicorp to build its skyscraper under one condition. A new church would have to be built on the same corner, with no connection to the building. Since the city was suffering economically, most local architects were fearful that designing a building of this magnitude was too big of a risk. But architect Hugh Stubbins was willing to roll the dice. His intention for the Citicorp Center was as righteous as the church that owned the land. Across the world, the 1970s was a period of great economic hardship. Cities like New York and Chicago had endured some of its worst residual effects. As many corporations were forced to close their doors, many people lost their jobs. So when plans for the Citicorp Center were underway, the community rallied together to do whatever they could to erect a building that could defy the odds. The center was conceived on the back of a paper napkin, the architect's pre-digital sketch pad.
The architect Hugh Stubbins and the engineer William Le Messier came up with this idea of 4 legs which lift the building up above the church, and those legs are not in the corners where it would be ideal, they're in the center of the building, which provides a very unique ground floor experience.
Le Messier designed a system of stacked load-bearing braces in the form of inverted chevrons. Each chevron would redirect the loads to the center, then downward into the ground through the columns. Unfortunately, the building's chevron pattern of structural bracing did not account for one major design challenge: the wind, an issue brought to Le Messier's attention a year after construction.
And he had a very kind of moral quandary about what to do, because his reputation was on the line at one hand, but on the other hand, the safety of the building was on the line. What happened was he approached the owner of the building, and at night they re-welded all the joints in the chevrons of the building. So at night, apparently, you could see the welding torches repairing or improving the building to increase its structural performance.
Working throughout the night, emergency construction crews took immediate action to rule out the possibility of any future catastrophic failures to the building.
So it really is a story of the difference, what can happen if we change a bolt and a welded plate, the importance of the detail in the structural performance of a tall building.
It was one of the first towers that was still modernist in its image, but it had a rake top. It was not a flat top. But it wasn't the only one that was trying to do that. So from the 70s, we start to see a shift from the flat tops. And so perhaps the architect that publicized more this new approach in tall buildings was Philip Johnson.
Compared to the 70s, the 1980s was a time of restrained optimism in New York City. Even though businesses were booming, the decade was described as a colorful conundrum of haves and have-nots, and set the tone for the rise of a new era of architecture. Deconstructivism. As one of the most influential American architects of the time, Philip Johnson embraced both international and postmodern architecture, mixing his unique eye for form with a minimalistic aesthetic. Johnson yearned for a return to the golden age of the skyscraper.
It was the famous, motto of Philip Johnson: I'd rather be interesting than modernist or monotonous.
In the 20s, they were building these beautiful buildings, Art Deco. But then, under the influence of Gropius and Mies van der Rohe, they start to build these just boxes.
Modern buildings were seen as becoming too anonymous, too ubiquitous. The glass box skyscraper became developed over and over again. It lost some of that purity and luster that it had originally.
It lays the groundwork for postmodernism in many cities, and many countries too, an appreciation of older buildings, an appreciation of masonry as opposed to steel and glass, an appreciation of ornament, and trying to create ornament out of new materials even.
Ultimately, tall buildings were going back to the origins of the skyscrapers in New York, with the spires and the need to advertise their space in order to find enough tenants.
Everything old was new again.
Postmodernism enabled architects to look back at historical styles, to reconsider them, and to re-employ them, and enabling buildings once again to have scale, which had been kind of ignored.
Rising from a sea of glass in Midtown Manhattan, the building's impact on the history of postmodernism and Johnson's legacy was a huge win for New York City and a new age of architecture.
The AT&T Tower is perhaps the best example of a postmodern skyscraper, a rejection of the functionality and restraint to the glass boxes that came in the decades beforehand.
Despite prolonged criticism, Johnson's AT&T building proved to the world that an evolutionary phase of architecture had officially arrived and was here to stay. In a word, American architect Philip Johnson's AT&T building was monumental. Standing 647 feet tall, this 37-story high-rise skyscraper located on Madison Avenue immediately stirred up its fair share of controversy.
It certainly became a symbol of postmodern high-rises in the 1980s, with its kind of Chippendale top, as it was derided in some ways, but also praised in many ways.
The building also referenced historic forms from the Romanesque and Florentine Renaissance. The entrance was modeled on Brunelleschi's Pazzi Chapel colonnade.
But for me, its best feature is its generous public entrance, a 7-story archway, a kind of heroic kind of entrance to the building at ground, clad in glass and ceramics. It's beautiful.
Postmodernism is like the third rail. Every time you bring it up, people are going to react to it in different ways. And I always say there are two ways to look at postmodernism. One is with the capital P and the other is with the small p. One is what follows after modernism and the other is a style. And the style is problematic because appropriation and exaggeration of classical ornamentation and just applying it to everything was a big problem in that style.
Structurally, the AT&T's design was inherently modern. Supported by a tubular frame, its columns connected with trusses at the top and the bottom. But instead of using modernism's customary glass curtain walls, the building's steel body was covered in pink granite. While the AT&T building remained respectful to the other buildings on the block, Johnson's next postmodernist monolith showcased a daring shift from the grid. Located on 53rd at 3rd, the Lipstick Building was quickly dubbed an oval building in a square environment, due in part by the unique way in which its soaring setbacks telescoped out of the skyscraper's curved shaft. There's no denying Johnson created a building that attracted attention.
Skyscraper traditionally has been an expression of a particular sort of approach to, let's call it late capitalism, a particular way of living.
The tall building adapts itself to the new culture and carries on. Philip Jones is starting to understand, for example, the so-called cost-quality paradox. You could invest a little bit more on the image for a greater return, rather than being like everybody else.
The polished pink granite was dramatic and expensive, which enticed many wealthy tenants to move in. But fortunes can turn on a dime, a brutal reality many people experienced in the late 1980s. October 19, 1987, also known as Black Monday, was a dark day for the Dow, when it recorded its biggest one-day percentage drop in history. The fate of the skyscraper industry and its ties to the cycles of big business have always been a subject of speculation. But no matter the location or the decade, some economists believed the height of tall buildings acted like economic measurements, predicting either booms or busts.
The Skyscraper Index was developed by an analyst called Andrew Lawrence, who convened a study where he created a very strong correlation between the completion of the world's tallest building and widespread financial collapse. So, for example, the Chrysler Building and the Empire State Building in New York coincided with the Great Depression. Completion of the Petronas Towers in Kuala Lumpur coincided with the Asian financial crisis, and then various other examples as well.
He sort of drew this conclusion that when the world's tallest buildings are completed, we should, head for the hills. Okay, it's very easy for us to create patterns that don't exist.
To a certain degree, they are hostages to fortune. You might start a building in a boom and finish it in a bust, or vice versa. So they are more difficult to predict than something which is simpler and shorter in program.
If you look over time, the tallest buildings are always at the end of the bubble. Everybody's really interested in real estate. They think prices are going to continue to go up forever. And so you build a really tall building, and then by the time you finish building it, the market has turned. And that's all about these economic cycles, because people don't go to build tall until they're feeling that heady environment in the economy, and then eventually it turns. So the job of a real estate developer is try to make sure they understand where they are in that cycle. You got to catch it right.
Whether consequential or coincidental, skyscrapers have always provided a way to stimulate economic growth and utilize new technology. And while the function of skyscrapers remained true to their cause, in the 80s and early 90s, their form continued to surprise and inspire worldwide.
The story about the skyscraper then is about the movement away from the United States.
Those cities are actually competing on a global stage, and they use these landmark buildings to signify their prosperity and progress. There's no doubt about that.
These buildings define a kind of center boast of the modernity of that place and its suitability for business.
You come to a city and you see these edifices and you're impressed, rather than this landscape of low rise.
first high-end companies will move in. And also we bring in a lot of modernization with all the infrastructure associated with that and all the jobs that is created, and also really bring the existing city into a next level of modernization.
Hong Kong, 100 years ago a rocky, inhospitable island, is today one of the world's busiest and most crowded cities.
By the mid-80s, Hong Kong was already bursting at the seams. Despite a decade of relatively slow growth, it was still one of the most heavily populated cities on Earth.
An excellent example of a city where the towers are integrated into the infrastructures is Hong Kong. You know, you've got one of the world's best mass rapid transit systems, points of density and towers built on and around stations. And what that means is most people live within a 500-metre, an 800-metre walk of a transit stop.
While other architects across Asia were concerned that too many skyscrapers might affect the spiritual context of an urban environment, architects in Hong Kong were focused on how they could add more to its skyline.
I did a lot of work in Hong Kong, and Hong Kong is just an adrenaline rush of how on earth we're going to build in the locations we're building, and certainly in terms of those high density areas, literally building 2 or 3 meters next door to another building as well. So that was pretty challenging. But I think just the speed of construction and how you go from the drawing side to the construction side, that was the huge challenge, because getting buildings up, getting people in was the key driver for developers. I've never seen anything like it.
Hong Kong was determined to become the #1 city in the world to do business by providing a bridge between the East and West.
The world's most expensive new office building. It cost about £600 million, and even the critics applaud the revolutionary design, which allows the maximum space on a confined site.
Norman Foster's ultra-modern HSBC building dominated the shores of Hong Kong's harbor in the mid-1980s. The building was seen as a major architectural triumph by incorporating the ancient Chinese practice of feng shui without compromising on cutting-edge design.
HSBC questioned at the most fundamental level all the high-rise buildings that had gone before. The high-rise building before HSBC had been a central core with a ribbon of space around that. The central core, escape stairs, elevators, washrooms, mechanical plant. So by taking that and fragmenting it, breaking it down into smaller pieces, and then creating lofts and putting those smaller pieces at the end, so you could see through the space, unbroken space. You could see the mountains at the back, the water at the front, Statue Square.
Inspired by the relationship between mountain and water, the 12-story glass and mirror atrium symbolized the bank's ability to hold on to money. The position of the escalators helped to channel energy into the skyscraper, and the building's open plan encouraged communication between its occupants.
The key challenges are connectivity with the workmates. If you've got an office which is split over 3 or 4 floors and the only way to commute between those floors is the lift, you lose a lot of opportunity for interchange of ideas and for, cross-pollination.
Creativity is all about communication. So if I can see you and I don't have a big wall in between you and me, then we're going to have a more enjoyable exchange.
The absence of the building's 4th floor was intended to create space and a sense of community. The architectural decision was intentionally made to align with local tradition.
Hong Kong, it's really tight. You have Statue Square. Everybody's bursting for space. It's so intense, the incredible energy, the density. So the opportunity to lift that tall tower above the ground plane, extend Statue Square through underneath the building so it becomes a major civic space.
The design process is a complicated one. The site, the budget, the function, and the overall aesthetic are key factors that need to be taken into consideration.
Design should be an answer to a problem. So we hold ourselves to the task.
You can't design a building in 3 moves. It's too complicated.
As architects, you advocate. You don't have a power to say it should be like this. But what if this, and these are the reasons why, and there's a good argument, then that becomes something which is kind of bonded and shared and finally realized.
Architects, they're always looking for something new to do, but they also want to know their options. You know, a lot of architects actually appreciate a few constraints. The way we work with architects is we try to guide them into solutions that'll meet the goals that they have. And of course, the developer, you know, he has goals too.
It requires me as the designer, in a way, to check the ego or the preconceptions and allow for everyone to have a voice in the design, because as we know, innovation is occurring at the intersection between disciplines.
So it's about then bringing in the practicalities to say, okay, how can we meet that, make it practical, make it buildable, make it affordable for the client to build at the end of the day.
It's not an equation. Put the numbers in the right sequence, you're going to get an answer, a fixed answer at the end. It's not that. It has to be designed that means something.
As the 80s turned into the 90s, an entirely new age for architecture began to establish roots. Unlike traditional practices, where functionality and design controlled how a building was created. Now, the priority to adopt sustainable initiatives became a crucial component in building construction. The 1990s ushered in a new wave of change. Advancements in technology drastically influenced the way in which people lived and communicated. In terms of architecture, one very vital truth became alarmingly clear. In order to preserve a building's life cycle, the future was sustainability. Germany established itself as a pioneer in environmental sustainability. Greening the economy was seen as both a social and political imperative. Given the nation's high population and scarcity of natural resources, taxing energy sourced from fossil fuels encouraged the development of alternative technologies. Green roofs and facades and permeable pavements were just 2 innovations German planners embraced as they strive to create an energy-neutral future.
I think some of the best tall buildings in Europe are in Germany, you know, with double skin walls, with natural ventilation strategies. You know, one of the best towers that has ever been built was Norman Foster's 1997 Commerzbank.
For many years, the Commerzbank building in Frankfurt was the tallest skyscraper in Europe.
Commerzbank, at its time, became the first ecological tall building, the first building to be, again, working with nature, to be breathing.
The building was positioned in a way that took advantage of the sun and wind, providing natural ventilation and light to every office in the 53-story tower. To more effectively utilize the climate, lead architect Norman Foster and his team developed the Klimafasade, a custom-made double-skinned envelope system that housed special motorized Venetian blinds.
At that time, as we saw it, for some 65% of the time, the climate would be such that you wouldn't need to heat or cool, and you could have the freshness of contact with the air outside. There were 2 kinds of working space. There were those on the outside of the building looking out to the skyline, and those that looked into the gardens. And then in no time at all, the most popular spaces became those that looked onto the garden. And I think here there's a social dimension coming in.
It took another 10, 15 years for another building to surpass what it did in terms of its commitment to communal space within the building. No matter where you work in that building, you have a direct connection to a sky garden, and there are a series of sky gardens that step up around the building.
It comes out of the street pattern with relatively low buildings. Those are replicated, and then you enter, you ascend, and it's a shared space, a restaurant, public. It's shared by the community of which they're a part, with an awareness that there's the private world in the tower, but that's in a very public domain, so somehow that fusion of the two is critical.
Without compromising the tall building aesthetic, Norman Foster completely reinvented the skyscraper. With every detail intentionally designed to connect and engage the community and to save or produce energy. The Commerzbank Tower set the tone for building to the sky in the 21st century.
My colleague and I have contended that we're possibly into a fifth skyscraper age, which is more specifically performance-driven. And we see this particularly with sustainability and the need for more environmentally and ecologically sensitive buildings.
More than half of a building's energy goes into its construction, depending on where it's located. That's because there's just a lot of, let's say, heat that's required to melt aluminum, for example, or how far those materials have to travel to get to the job site, because the trucks or the trains that are carrying those materials also consume energy.
Sustainability is a global requirement. It's not a trend. It's a necessity.
For our continued survival on this planet, it's not enough for a building to just do the best it can by the building.
The revolution that's happened has to do with the sustainable imperative that buildings have to do better in energy performance.
We're constantly looking for that magic moment where the envelope is as thin as possible but performs as if it's not there.